Okay, so this is grade 12 applied, probability unit lesson 3. So we're going to talk about exclusive events and inclusive events, and we've already covered those before. So let's do an example. So Janek and Violet are playing a game. To move on the next turn, Janek needs to roll either doubles or a sum of 7 with 2 standard dice. Now, here's the deal. Rolling doubles or a sum of 7 is exclusive. Why is that? Because these events cannot happen at the same time. There's no doubles that add up to 7. So what we can do here is let's create our event A. Event A is rolling doubles. Event B is rolling a sum of 7. And we just created a chart over here. So what we have is rolling 1 die on the top, 1 die on the side here. And you can see all the patterns here that we can do. So all the doubles are circled, right? So there's 6 of those. And all of the sums of 7s you can see are underlined that way. Okay, so there's 36 in total. So event A is rolling doubles, event B is rolling a sum of 7. So the probability of A or B, right? Remember, or addition. So 6 over 36 plus 6 over 36 is 12 over 36 for a third, right? So that is the probability of rolling an A or a B. Okay, flip page, go to example number 2. On the same game, Janek and Violet are playing. If the player rolls a sum greater than 8 or a multiple of 5, they get 100 bonus points. So now these are inclusive because you can have a sum greater than 8 and you can also have a multiple of 5, right? 10 would be the one. And if you look back, there's multiple ways on the previous page of getting a 10. If you look over here, right? 4, 6, 5, 5, 6, 4, right? So there's the ones there. Okay, so these are inclusive, so it's a different formula. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. That's the overlap part if we were to do Venn diagrams. So probability of A, 10 over 36, probability of B, 7 over 36, and the probability of A or B, that's that 3 over 36. So we add them and then subtract. So you end up with 14 over 36 or 0.388 repeater or approximately 39%. So those are inclusive events, so they could not happen at the same time. Okay, let's go to example number 3 on the third page there. A newspaper published the results of the recent surveys that states. Okay, so what we have is 62% of students skip breakfast. There's event A. 62 of them skip the whole thing. So now don't forget this whole thing's out of 100 because it's in percentage. 24 skip lunch, and 22% of the students eat both breakfast and lunch. These are inclusive, right? So what we got to do is we got to look at, okay, so determine the probability that a randomly selected student skips breakfast but not lunch. Breakfast but not lunch. So we're looking for breakfast but not lunch. So that you'll see we have the number here already, but I'll show you how to get there. So how do we get the 78? Well, 22% of students eat both breakfast and lunch, so 78 skip something. Okay, so what we do is we take the 62, the 24, and the 22. That's our total, and it comes to 108. Now, of course, the total is out of 100 because it's a percent, right? So 8% must skip both. Okay, so the 8% that must skip both is the center of the Venn diagram way over here. Okay, so if we know the center is, well, that's easy. 62, so this whole circle has to be 62. So 62 minus 8, we get our 54. 62 minus 8 is our 54. Must skip breakfast, but not lunch. Okay. Go down to B. Determine the probability that a randomly selected student skips at least one of breakfast or lunch. So skip one or the other or both. So we get 54, the 16, and the 8, 78%. Okay. Or if you want to do it formula-wise, 62 plus 24 minus 8, that's what we're trying to do here. So probability of skipping breakfast or skipping lunch equals the probability of skipping breakfast, the probability of skipping lunch minus the overlap, right? So 64 plus 24 minus 8 or 78. 2 ways of doing it. Either one is acceptable when you're trying to figure this out. Okay, let's go to the last page and do one last example in this lesson, which is car manufacturing keeps a database of all the cars in Western Canada. For Model A, that's the car we're talking about here, the database reports that 43% have heated seats, 36% have a sunroof, and 49% have neither. Okay, so event A, heated seats, 43. Event B, sunroof, 36. Okay, now we don't know about the overlap because it could be inclusive. Some of them overlap. So what we do here, since it's in total, right, we can look at 49% have neither. So 100 minus 49 equals 51% have something. We don't know what it is. Could be heated seats, could be sunroof, whatever it is. So have something. So then we look at, okay, 43 and 36 is 79. Remember, That's the heated seats, right? That's the heated seats. That's the sunroof. So equals 79. So when we subtract those two, the 79 minus the 51, 28%. So 28% have a chance, chance the Model A has both. So the 28 goes in the center. Well, then you can figure the rest of this out, right? The 15 and the 28 total up to the heated seats, and the 28 and the 8 total up to the sunroof. And then you can figure out, well, the 49, right, is they have nothing over here. Now, to do that with a formula, you can do it as follows. Probability of A or B equals the probability of A plus the probability of B minus the overlap. Now, here's the interesting thing. We don't know what the overlap is. That's what we looked on the last question. So the probability of A or B is 51. Probability of A is 43. Probability of B is 36. Well, there's our unknown, the X here. Well, this is just basic algebra, right? Collect your like terms here, the 43 and the 36. Yeah, how do we get rid of the 79? Subtract the 79. Well, we have a -1 in front of the X. How do we divide that? Or how do we get rid of that? Divide both sides by -1. We end up with 28% equals X. And that's what we calculated on the above one, but that was with a Venn diagram, and this one's with the formula. You can do, again, either way. Both ways are acceptable. Okay, so that was probability lesson 3. Lesson 4 is coming up right away, and that's the last one in this unit.